So in this video, we're going to look at task 20, similarity from the packet. It's on page 32. So we're going to talk about similar figures. So we did congruent figures, and congruent figures are the same shape and the same size. But there's another thing called similar figures. So think about when we do dilations. Dilations do not create congruent figures unless they are not isometries. However, they do create similar figures, or figures where the angle measures remain the same, but the length of the sides are different. However, the lengths of the sides are proportional. In other words, they are all different by the same scale factor. Okay, so from the smaller to the larger figure, they're all like multiplied by the same number. Okay, if it's a bigger enlargement, then they were multiplied by a scale factor that was greater than 1. If it was a smaller reduction, it was multiplied by a scale factor between 0 and 1. But they're all the sides were multiplied by the same number to get the new side. So because of this relationship, the following proportional relationships can be set up between any two similar triangles. We can take the length of one of the sides, and they say like side A, so they're just talking about if I have two triangles, and I'm just calling this side A, okay, and not naming it by the vertices. So I could take the length of this side, whatever it is, and divide it by the length of the image side, and that should equal the length of the other side of that pre-image divided by the image side, and that should equal the third side being divided by its image side. And for this, when we're doing similar figures, we're mostly going to do similar triangles. It doesn't matter if you put the image or the pre-image on top, and we're not really going to know which one is the image and which one is the pre-image. In this case, they'll give you two triangles with different sets of vertices, but all you have to do is be consistent. So if I put this triangle side lengths on the top in the first ratio, I'm going to do that in every other ratio. We use this one mostly. This is also true, but we're not going to really do this. But you could do the length of side A divided by whatever this angle measure A here across from it. That is going to equal the length of side B divided by this angle measure B, and the length of side C divided by that measure angle C. Okay, but we don't really use that, so I wouldn't worry too much about that. Okay. So just like when we had triangles, there were ways to prove them triangle. There are ways to prove triangles similar. There's 3. Okay, there's not 5, there's 3. So angle, if two angles of two different triangles are congruent, then the triangles are similar. And note that if 2 of the angles are congruent in a triangle, then the third one also has to be congruent since they're going to add up to 180. So if I have 2 triangles, again, they're going to be the same shape, but different sizes. If I know that 2 pairs of angles are congruent, it's going to be hard, but this is marked. This is the same marking as this one. If I knew 2 of them are congruent, then I know that the 2 triangles are similar. So I don't need to know anything about their sides, but if I know 2 pairs of angles are congruent or 3 pairs of angles are congruent, then they're similar. And for this, we have a similarity statement. It's the same as the congruent statement. So I'd have A, B, C, but we use this symbol. This means similar. Okay. So again, this means congruent. And then just the simple, it's called a tilde, means congruent. Nope, sorry, means similar. So triangle ABC would be similar to triangle. And again, you have to match them up with the corresponding parts. So A went with D, B went with E, and C goes with F. So that's angle, angle. So then we have side, side, side. So side, side means all three corresponding sides of two sides are proportional. So they're not going to be congruent, or they don't have to be congruent. They could, but they don't have to be. They need to be proportional. So what that means is if I have a triangle A, B, C, and I have another triangle D, E, F, and I'm given the sides of this triangle, the scale factor has to be the same for each pair of corresponding sides. So to find kind of the scale factor, we divide the one side of our triangle by the corresponding side of the other. When you do this, make sure you're not matching up by like the orientation, but by the numbers. You're going to determine like small, medium, large. So let me actually. If these are my sides, so that they're all a little bit different. When I find the scale factor, I find the smallest side on this side and the smallest side on this one. And then I divide the smallest side by the smallest side. And you can do either 2 divided by 4 or 4 divided by 2. It doesn't matter. I'm just going to do 4 divided by 2 because it's easier. So that's 2. And then I need to check that that's the same as the scale factor for the other two sides. So I'm going to take the medium side, which I have 2 is my smallest, 2.5 is my medium, 3 is my large in this triangle. 4 would be my small side, 5 is medium, 6 would be large. And the scale factor for that medium side would be 5 divided by 2.5, which is also 2. And then the scale factor for the large side would be 6 divided by 3, which is also 2. And so because they all reduce to the same scale factor, the sides are then proportional. And if all 3 pairs of sides are proportional, then we can call it side, side, side. Okay, and then again, we do our similarity statement. A, B, C is similar to triangle. And again, make sure you're matching up. So A to B is the small side. So I need D to E and then F. And then the third way is side angle side. So again, for this, we're going to have 2 corresponding sides of 2 triangles are in proportion and the included angle. So if I have these 2 triangles, what I would have to do is I would see that I have an angle and then I have a side length here and a side length here. And the same is true on the other triangle. So I have 2 side lengths and an included angle. I have to check that the side lengths are proportional. So to do that, again, I'm going to divide the corresponding sides. Now, again, be careful. 6 is the larger of the 2 numbers. 5 is the smaller. In this one, 3 is the larger and 2.5 is the smaller. So when I'm dividing to see, are they proportional? I'm going to do, and again, you can do 2.5 divided by 6 or 6 divided by 2.5. I find that students prefer the larger divided by the smaller. And I meant 6 divided by 3 or 3 divided by 6 because I'm going to match up the corresponding sides, which are the large ones. So I'm going to do 6 divided by 3, and that gives me 2. And then I'm going to do 5, which is the small side, divided by the other small side, And that also gives me 2. And so the sides are proportional. So this would be a side angle side. And again, you would write the similarity statement, A, B, C is similar to triangle. Okay, so in this case, it's large to small, the order I did. So I need to go large to small, so it'd actually be F, E, D. Just like congruent triangles, similar triangles should be named so that their corresponding angles and proportional sides line up, just like I did in all of the similarity statements. Okay. So we don't have angle, angle, side. We don't have angle, side, angle because they both fall into angle, angle. So we don't count those as ways. We just say angle, angle if you have either of those options. So those are the different ways to prove triangles similar.